Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. In our today's lecture, we will be studying about the functional groups. So before moving towards our main topic, let's discuss that what are the derivatives of hydrocarbons. We know that hydrocarbons are the compounds that contain carbon and hydrogen. Now, let's suppose that we have methane. Now you may see here that in methane there are only two elements present, carbon and the hydrogen. So it is a perfect example of a pure hydrocarbon. Now if we replace one of the hydrogen atom in methane with any other atom, suppose chlorine, then this compound will be written as this CH3Cl. Now you may see here that this methyl chloride is different from this methane, and since this methyl chloride is derived from methane by substituting hydrogen atom with chlorine atom, therefore this methyl chloride will be considered as the derivative of methane. What is methane? Methane is a hydrocarbon. So the derivatives of hydrocarbons are mainly obtained by the introduction of elements other than the carbon or hydrogen, or by the introduction of double or the triple bond. So the compounds that contain carbon, hydrogen and one or more additional elements are called as the derivatives of hydrocarbon. Now what are those elements? They may be nitrogen, oxygen, sulfur, phosphorus, halogens or the metal ions. In addition to these elements, double bond as well as the triple bond may be present within that organic compound. Now, when these elements or a double or a triple bond is present in an organic compound, then they give certain special chemical properties to that organic compound. Each group of atom or atom is limited to a certain set of properties, certain set of chemical properties, and with the help of the presence of these atoms or the group of atoms in an organic compound, we may predict the properties of that organic compound. So what are functional groups? Functional groups are basically an atom or a group of atoms that give a family of organic compounds its characteristic chemical and the physical properties. We have read in the previous slide that when we introduce certain new elements in an organic compound, then it totally changed the property of that organic compound. A new class of organic compound was generated. Now for each atom or a group of atom, there are specific chemical characteristics that are limited to that group. And those group of atoms or the atom is called as the functional groups. So why they are called as the functional groups? These functional groups show the characteristic chemical reactions, and when a certain functional group is present in more than one organic compounds, then those organic compounds behave in a similar fashion. How do they behave in a similar fashion? By showing the similar chemical reactions. So that's why they are called as the functional group, because for an organic compound their main function is to react with another organic compound. So in order to react, they need certain specific group of atoms within that organic compound, and those specific group of atom decides that what kind of chemical reaction will be occurring in a specific group or class of organic compound. So that's why these groups of atoms are called as the functional groups. Now, just by looking at these three examples, can you differentiate what is the difference between these compounds? First one is the structure of methane. Second one is the structure of methanol. Third one is the structure of methyl chloride. Now, if you look clearly, then you will see that first one is the hydrocarbon. This compound contains only carbon and the hydrogen. Now, if this hydrogen atom is substituted by the group of atom called as OH, then a totally different class of compound has been generated here. This class of compound is called as alcohol. Now, because of the presence of this group of atom, that is OH, all the organic compounds having this OH group will show similar characteristics, chemical characteristics, will show similar chemical characteristics. And the chemical characteristics of alcohol will be different from those of alkane. Similarly, if you look at the third example, in the third example, this hydrogen atom is being replaced by another atom, that is the chlorine. Now, with the introduction of chlorine atom, a new class of organic compound has been generated here, and this is called as the alkyl halide. All the chemical reactions of alkyl halides having this halogen group in that organic compound will show similar chemical characteristics. However, the chemical characteristics of alkyl halide would be different from that of the alkane. So what is the importance of functional group in organic chemistry? We know that millions of organic compounds have been discovered so far, and it is very difficult to study them individually. Now, since there are a few number of functional groups, so therefore these millions of organic compounds have been classified into few classes on the basis of the functional group. So when they have been classified into few classes, so the study of their properties have become easier. Each functional group in an organic compound defines a family of organic compound. For example, if we have three organic compounds and all these are having OH group, then we will know that these compounds belong to the family of alcohols. So the functional group decides that a certain organic compound belongs to the which class of organic compound or which family of organic compound. This study of organic chemistry generally organizes around functional groups. We know that chemistry is basically about the chemical reactions. So these functional groups or the specific group of atoms decides that what kind of chemical reactions will be occurring in in certain kind of organic compounds. Now, since these group of atoms are mainly involved in those chemical reactions, so therefore their study of these functional group is necessary in order to understand this organic chemistry. So these functional group makes the study of millions of compounds easier. Now let's discuss some common functional groups that are present in the organic compounds. So the first family of the organic compound classified on the basis of the functional group is that of alkanes. In the alkanes, the general formula is RH. Now, the R here is representing an alkyl group. and we have read about the alkyl group. For example, we have a compound that is methane. Now, if we remove hydrogen atom from this methane, then it will be converted into methyl group. Similarly, if hydrogen atom is removed from any other hydrocarbon or alkane, then it will be considered as the alkyl group. So for alkanes, the general formula is OR-H, and since there is presence of no other functional group because it is a pure hydrocarbon. Examples for alkane includes methane as well as propane. Another class of organic compound is the alkene. For alkene, the general formula is written like this. And the functional group in the alkene is basically the carbon double bond carbon. Examples for alkene include ethene and propene. Now in these two examples, you may easily recognize or identify the carbon double bond carbon in the organic compound, and the presence of this C double bond C is classifying them into a single family of compound, that is the alkene. So this C double bond C is the functional group of the alkene. Another class of organic compound is the alkyne. General formula for the alkyne is represented like this, and the functional group in the alkyne is the C triple bond C. Example for alkyne include ethyne, propyne. Now in these two organic compounds, you can easily identify the presence of C triple bond C, and since the same functional group is present in these two compounds, therefore they are classified in a single family of an organic compound called as alkynes. These two compounds will show similar chemical properties because of the presence of same functional group. Another class of organic compound is that of alcohol. Now the general formula for alcohol is ROH. This R is an alkyl group, and OH is the group of atom that is the functional group for the alcohol. So in the alcohols, the functional group would be OH, and this OH would be attached with any of the carbon atom. Example for alcohol includes methanol and the ethanol. Now in these two compounds, you can easily identify the presence of OH group, and this presence of this OH group is classifying them into a family of organic compound with the name alcohol. Another class of organic compound is the ether. This is the general formula for ether. The functional group that is present in the ether is COC. Oxygen atom is present between two carbon atoms in case of ether. Example for ether includes the dimethyl ether. Now in this example, this CH3 is representing an alkyl group, and between these two alkyl group a single oxygen atom is present. Similarly, another class of compound called as aldehyde have the general formula RC double bond OH. The functional group of aldehyde is represented like this. In all the aldehyde, a carbonyl group, that is C double bond O, is attached with the hydrogen atom on one side, and this carbon atom is of carbonyl group is attached to the alkyl group on the other side. So all the organic compounds having this group will be considered as the aldehyde. Example for aldehyde includes propanol. Sorry, this is propanol because it contains 3 carbon atoms. Now you may easily identify the presence of this group which is present in the family of organic compound named as an aldehyde. Now for ketones, the general formula is represented like this. The functional group in ketones is the carbonyl group, that is C double bond O. At one side of this carbonyl group, at both sides of this carbonyl group, 2 alkyl groups are attached. How will you differentiate between aldehyde and ketone? In aldehyde, at one side alkyl group is attached and on the other side hydrogen is attached. However, in ketones, on the both sides of the carbonyl carbon, 2 alkyl groups are attached. Example for the ketone includes the propanone. Now you may see here that a carbonyl group is present in the center and the 2 alkyl groups are attached on the both sides of the carbonyl carbon. Amines is another family of an organic compound. The general formula for amine may be represented like this or like this. In this case, nitrogen atom is attached to one alkyl group, and in the second case, nitrogen atom is attached to the 2 alkyl groups. The functional group for the amine includes the bond, that is C single bond N. All the organic compounds having the bond C single bond N would be considered as amine. Now the example for amine includes the methylamine. Now in methylamine you may easily identify the presence of C single bond N, and the presence of this bond shows that these organic compounds belong to the family of amine. Now we have the carboxylic acids. The general formula for the carboxylic acids is this, and the functional group of the carboxylic acid is C double bond OOH, and at one side of this carbonyl carbon alkyl group is attached. Example for carboxylic acid includes the ethanoic acid. Now in ethanoic acid you may easily recognize the presence of this carboxylic acid group. Another class of organic compound is that of esters. Now the general formula for esters is represented like this, and the main functional group that is present in esters is this: carbonyl group. Carbon is attached to the oxygen atom, and this oxygen atom is attached to the alkyl group at one side, and the carbonyl carbon is also attached to the alkyl group from the other side. So all the organic compounds having this group of atom will be considered as the ester. Example for the ester includes ethyl methyl ester. Now you may see here, this is the ester group. At one side of the oxygen atom, this alkyl group is present, which is ethyl. And on the other side, the carbonyl carbon is attached to another alkyl group, that is methyl. So these were the different families of organic compounds that were classified on the basis of the functional group present in them. In today's lecture, we just reviewed different functional groups. You after listening this lecture, you should be able to recognize each group of atom and should be able to tell that which organic compound belongs to which family or the class of organic compound. So this was all for today. We will be discussing about these classes of compound in detail in our upcoming lectures. Thank you for being with me.